Presenting you Stark Industries represented by Ishrat, Hunter, Manny, and Pooja. The big final competition is based on the matrix where we have a 7-foot by 7-foot arena with 4 home zones represented by the different colors yellow, black, blue, and white. At the center of the arena is the rotating matrix with Mr. Morpheus right in the middle on top. The starting zone, represented by the 30-inch by 30-inch rectangles, is where the machine is to be placed and launched, and the machine is to fit within a volume of 1 foot by 1.5 feet by 2 feet, as represented by the white box. The objective of the competition is to score maximum points by accomplishing a set of task requirements. Here is the house of quality that provides a better understanding of the problem and what is required of the machine in the final competition. The most important engineering requirements as shown in the house of quality are the failure ratio, which indicates the number of acceptable machine malfunctions at 1 failure per 30 runs, and points earned. The most important customer requirements include repeatability of task completion, ease of boxing the machine indicating it meets volume constraints, and scoring maximum points from programming modules, as programming modules itself can award a maximum of 56 points, which is a lot.
Here is the specification sheet for the final machine. The easiest specifications to achieve, seen here in green, include the distance from the start zone to the sentinel, as this distance is the smallest compared to other task components, and keeping the cost below $100 as most of the machine is designed and built using inexpensive materials such as wood, strings, and hinges. The most difficult specifications to achieve, seen in red, include the task requirements of Morpheus acquisition and pills deposition in the red zones, as these require the machine's respective subsystems to extend over a large distance, which is difficult due to the volume constraint of the machine.
Shown in figure 3 is the function tree for our final project. Perhaps the easiest task to complete is turning the machine on and off. This is because we have been given a standard banana plug start for each of our systems, and the runtime is strictly 40 seconds, which are both easily programmable. The hardest sub-functions are perhaps placing the pills in the red zones and retrieving Morpheus. These tasks require high repeatability as tiny track variations produce huge differences in lengths when the machine is extended all the way to the matrix. Shown in figure 4 is the morph chart for the final machine. It shows the possible solutions to each of the sub-functions of the function tree. Perhaps one of the harder sub-functions is the detection of red zones, since there are a lot of factors that could throw this off, such as track variations and faulty code. The ME2110 is an amalgamation of the best subsystem designs that were proven successful in the testing phases of each subsystem. It has 4 major subsystems that perform the tasks: the pill subsystem, the sentinel engagement subsystem, the programming module subsystem, and the egress subsystem. The pill subsystem rides on a platform mounted on a 22-inch drawer slide that extends all the way up to the matrix. The pills are deposited through a PVC pipe with 2 solenoids that are each activated by the detection of beacons by a roller switch. The Sentinel subsystem consists of a hinged arm with a claw at the end that falls over and ahead of the Sentinel when the machine is deployed. Upon egress, this hook gently picks up the Sentinel off the track and reels it all the way back into Zion. The programming module subsystem is comprised of 2 falling arms that are pushed out and in front of the programming modules with the force of a pneumatic actuator connected to a programming module extender. The ME2110 costs a total of around $50, which comes well within the $100 cost constraint.
The first design alternative features simplistically designed subsystems that are intended to be robust. Working from top to bottom, the Morpheus retrieving arm consists of a lobster loop-like grasping mechanism fabricated from a sponge that is then constricted. The pivot arm can then be retracted to the haven of Zion. Underneath the retrieving arm platform, two pill deposit tubes are fastened side by side. A retractable Sentinel bulldozing arm located on the base is flanked by two module capturing arms that bring modules back into the home zone.
The second concept alternative is the ME-Robot. The ME-Robot uses retractable arms powered by pneumatic actuators to collect the programming modules by knocking them into the home zone. A retractable arm hooks onto the Sentinel and brings it to Zion when pulled by the string and motors. When the drawer sliders fully extend, a roller switch detects the beacons corresponding to the red zones and deposits the pills when the solenoid is activated. Morpheus is captured by a net attached to a retractable arm that can later be rolled back with the entire secondary platform, bringing Morpheus back to Zion. The third concept alternative, the Dreamcatcher, makes use of gravity-powered sweeping arms to collect the programming modules. A hook is launched over the Sentinel by a pneumatic actuator to capture the Sentinel. Drawer sliders extend the secondary platform closer to the EMP zone, which allow Morpheus to be captured. A retractable arm containing a Dreamcatcher-like pattern of zip ties entangles Morpheus and brings him back to Zion. While the secondary platform is extended, a roller arm switch clicks against the beacons to detect each zone of the EMP blast zone and deposits two pills in each red zone. The next concept alternative, the Sagittarius, uses drawer sliders as well to approach the EMP zone. Morpheus is captured by a grasping mechanism and brought back to Zion via string and falling weights. Simultaneously, a roller arm switch differentiates the red and blue zones and deposits two red pills in each red zone. The Sagittarius also uses two pneumatic actuator-powered retractable arms as well as a sweeping arm to collect the programming modules and expel the Sentinel out of the home zone.
This third-level evaluation matrix illustrates the prominence of the Mark 42 design. Easy to box and repeatability of task completion criteria both scored highest with a rating of 4, while also having the highest importance. Designs such as the Dreamcatcher and the Sagittarius scored very low across the board due to complex subsystems that contained several moving parts and functioned inadequately. With similar design aspects to the Mark 42, the collinearity design ranked second with a high relative total. A high relative total among machines with similar designs signifies strong subsystems and robust designs.
The big design competition took place last Friday, and the table here demonstrates the results of the Mark 2110. It can be seen that the egress subsystem was the most robust system as the machine successfully egressed in all 4 rounds of the competition. The pill subsystem successfully delivered 2 pills into one red zone during the second round, but failed to deposit pills in the other rounds because the subsystem failed to reach the beacons for the rolling arm switch to detect the red zones. This happened because the string used to extend the subsystem entangled with the wires of the system, and the machine's building process did not account for track variances, leading to inconsistency in the pill subsystem's performance. The Sentinel subsystem, which used a hook arm to grab onto the Sentinel during egress, failed in all 4 rounds, primarily because the weight and friction of the Sentinel was not accounted for during the building process of the machine. Additionally, hardware, especially the hinges, allowed too much lateral movement, resulting in the extending arms vibrating and flexing in directions that were not expected and thus not accounted for, causing the machine to decrease its performance consistency, resulting in underperformance, especially for the programming modules and the Sentinel. Although the machine did not perform as expected, it was able to progress to the 4th round of the final competition due to the poor performance of competitors, leading them to either be disqualified or score less points than the Mark 2110. The biggest strength of the final machine is its use of standard fasteners, as it made it easier to repair between rounds, and the ease of boxing, as the machine was built keeping volume constraints in mind. The machine's weaknesses included its excessive use of string that interfered with wires within the machine and the hairpin trigger system for the pills. In addition, the machine did not incur trial runs prior to the competition, resulting in its inconsistent performance as it did not account for track variances. Future design improvements on the final machine will take into account the performance issues faced due to the machine's weaknesses and correcting wrong assumptions made during the initial design process. Therefore, less string will be used to prevent entanglement with internal wires. A more reliable triggering mechanism for the pill subsystem will be employed. For the programming module subsystem, sweeping arms will be considered instead of the current extending retractable arms, as sweeping arms used by competitors in the final competition proved to be more effective in collecting programming modules despite interference from other machines. Additionally, more precise methods of manufacturing, higher quality hardware, and tools such as laser cutters will be used to machine and assemble each part and subsystem respectively. Finally, more emphasis will be given to testing and trial runs to ensure performance robustness. Thank you. We would now love to take up any questions.